everyone, we are here again and we are still learning sets. And today we are going to be looking at operations on sets. In our last videos, I introduced what sets are. I tried to give some examples of what it looks like and explain some terms in sets. And we've also looked at some ways of writing sets. There are two ways of writing sets: the listing method or the roster method. And we've also looked at the types of sets. Now today we're going to be looking at the different operations that can be done on sets. There are 5 major operations that can be done on sets, and we're going to be looking at that. So the first one, there are 4 major operations that can be done on sets, and that's what we're going to be looking at today. Join me as we go straight into the video. The union of sets. When I talk about union of sets, the union of 2 sets, let me say A and B. The union of 2 sets A and B is written like this. When you see A union B, we are talking about the union of A and B. A union B is the union of A and B. Now, the best way I love to explain union, I prefer to use the term of marriage. You know, marriage is a union. Yes. Coming together of 2 things, a combination, joining. That's what union is. If you bring 1 or 2 things together, that's what we talk about with union. Bringing 2 or more things together. Example, if A is, let's say A is A, B, C, and B is A, E, I. If I talk about A union B, it's going to be a set of elements that belongs to both A and B. So the union of 2 sets, A and B, is a set of elements that belong to both A and B. So what we're basically doing is to combine the elements of A and B. But remember, in sets, the arrangement doesn't matter. And also, you don't repeat elements in sets. So if we can notice that A appears both in A and B. We are not going to write 2 A's. Just 1 A is enough to say that there is A in the union of the 2 sets. You don't repeat any elements. So the combination of these 2 sets, and I like arranging them alphabetically. So bear with me. This is going to be A, B, C, E, I. What I basically did was combine the elements of A and B together. That's what we say union of 2 sets. And I hope you know that. Then when we talk about the second one, is intersection. Intersection of sets. Intersection of sets is the second one. Now what this particular operation of set is just saying is that when we are talking about intersection, we are looking at what is common between these 2 sets. That's basically what intersection is all about. What is common? What is in the first set that is also in the second set? So using in form of definition, I would say that intersection of 2 sets is a set of elements that belong to both A and B. It's a set of elements that belong to both A and B. Example, if A is 1, okay, before the example, so elements that belong to both A and B. So the intersection, we show it with an N. When I write A and B, that's A intersect B. When you write U, it's talking about union. But when you write N, it's talking about intersection. So A intersects B. That's how we show intersection. Now, if A is 1, 2, and B is 1, 3, 5, A intersects B. It's asking you what is in A that is also in B. A union B is asking you to bring the elements of both sets together. Why A union B is asking to bring the elements of the both sets together. Why A intersect B is saying what is here that is also here. As simple as that. So that is 1 is here, 1 is here. So A intersect B is just 1. I hope you can write your curly brackets now, or are you still finding it difficult? Anyhow, just coils. Anyhow, you write that. So that's our A intersect B. So we'll now look at the third one. The third one is what we call complement. Complement of sets. Now, what this one is literally saying is the complement of a set is just talking about a set now. Complement of a set are those elements that do not belong to that set, but belong to the universal set. I hope you remember universal set, the mother set, a set from which other sets are formed. So, and we show complements with, if I'm talking about complements of A, it's either I write it this way or I write it this way. Either with a small c to show complement or with prime. So when we say A prime, we're just talking about A complement. So we show it this way or this way. So if my universal set is 1, 2, 3, 4, 5, then and my A is 1, 2. A complement is just asking you what is not an element of A but can be found in the universal set. Like it's asking for those elements that are not in A but are in the universal set. So you now check 1, 2 is A. That means what are the other elements that can be found in the universal set? That's 3, 4, 5. That's our A complement. So A complement, B complement, C complement. Complements of any set is asking what are those elements that can be found in the mother set but are not in that set. Then we also have the fourth one, difference of two sets. Now, you know, if we are talking about difference, we're talking about subtraction, right? So our difference of two sets can come in two ways. Let me say if A is A, B, C, D, and B is A, C, E, F. Now, we can have A minus B or B minus A. Our difference of two sets can come in two ways, either A minus B or B minus A. Now, what is the difference of sets saying? The difference of two sets, A and B, is a set of elements that belong to the second set, B. Difference of two sets, A and B, is a set of elements that do not belong to the second set, but belong to the first set, A. So in layman terms, what I tell my students is, once you want to look at A minus B, they are basically asking you to remove all elements of B from A. So you look at A and B, what is common between A and B? If you find those elements that are common between A and B, your focus should be on the first set. So you take out all those elements that are elements of B from A. So difference of two sets is asking for those elements of A that are not elements of B. It's asking for the elements of A that are not elements of B. So you now check what are the elements of B that are in A, remove them. All the elements of B that are in A, remove them. So now if you observe, this A is in A and A is in B. C is also in A and B. So the two elements that are elements of B, they are also elements of A and C. So we'll remove it from A. If we remove A and C from A, what will remain? B, D. That's A minus B. But when we are looking at B minus A, we are trying to remove the elements of A from B. Any element that is an element of A, we remove it from B. So more like we are looking for B only. So you now, because B came first, you focus on B. Then ask yourself, what element of A is also in B? So A and C, you remove it. If I remove A and C from B, what will remain? E, F. Now, your focus should always be on the first set. You are removing those ones that are common between the two sets from the first set. You are removing those ones that are common between the two sets from the first set. And this is how we achieve this. I've seen the 4 operations that are performed on sets. These are the 4 operations. So in our next video, I will use Venn diagram to explain these 4 operations before we solve some examples on them.